So, as you can tell, my name is Brian Carpenter, and I work at Pure Storage. Today's conversation is around modernizing your IT infrastructure for AI. Having read a lot of the badges that are in here, there doesn't seem like there's a lot of infrastructure people here, so I'm going to twist this into information you can hand to infrastructure people when you get back to the office. How's that sound, right? So, and there are going to be some infrastructure people in here. I won't make you raise your hands, but we'll go over exactly what this means to you as well. So, the first thing is, like, what are we talking about? Why do we need to modernize? Obviously, what are the pain points around IT infrastructure for AI? You know, we talk about AI a lot of times, and we focus down on something as simple as the GPU. And while what's inside of there is amazing, the people like NVIDIA and AMD and everybody else has done a great job, TPUs, all that kind of stuff. There's a ton of things that happen before you get to the GPU. We'll focus on what those struggles are and how people are solving them. And we're going to help IT be the hero in data science. And, you know, candidly, I give this presentation a lot with a coworker who is a data scientist. My view into the world is I came from the infrastructure world and learned a lot of the data science challenges along the way. And there's a bridge that has to be built. There's a lot of things that data scientists know, and there's a lot of things that IT people know and they've been doing for a very long time. And what happens is both sides look at each other and go, I'm not supposed to know that thing. But in fact, there's so many major impacts around both sides that you really have to understand to be successful. Otherwise, you end up in these pain points. So the first thing is modernization, which I apologize for the spelling, but we'll fix it on the next one. There's supposed to be an S there, I think, right? Deep learning execution flow. We can look at things like exploration and training all the way through QA and deployment, and this is the way we look at it, right? And it's very simple, sounds really easy, maybe not. So the first thing is, let's look at it a little bit different. You spend a lot of time doing things like exploration. And when we see exploration, we talk about things like data subsetting, data validation. Is this anybody's favorite part of their job? I mean, do you brag about how you data subsetted some stuff yesterday? The answer is probably not, but you might go out and talk about how you built some sort of convoluted neural network and, you know, there's a GAN that was hanging out and all these kind of things. We talk about those things because they feel good to talk about. There's a ton of things that happen beforehand. These are one of them. But the one we really want to talk about and focus here is on the actual training, okay? And when we look at training, we're talking about things like banging around on hyperparameters, right? We really want to optimize that model. We want to get as close to zero as possible. We also want to do things like model exploration. We might want to try 8 different ways of looking at it. But I'm going to tell you that that's not actually all the time you spend in training. Again, we might talk about hyperparameters. What we don't want to talk about is all the time we spend loading data. Okay, so if you're in here and you're looking at me right now and you're like, look, I'm in the cloud 100%, by the way, that's still infrastructure, and you're like, my data set is 1 byte, that's great. At some point, as you scale what you're doing and it turns into a real production application that has to be managed in production as a model, there's going to be data with it, right? It's going to have gravity, it's just a matter of time. Sometimes you're going to manage that on-prem, sometimes you're going to manage it off. A lot of these principles apply on both sides. We typically see it on-prem, obviously, from our position. So you're saying, okay, great. You talked about all these great things that you're doing, but what I really want to do is I want to ship my product. You start with something as simple as a GPU server, but eventually it turns into something like this. And you look at me like, okay, I don't care about the infrastructure. How do I ship my product? Okay, but let's look at it again. GPU server, more GPUs, your infrastructure, your switching, your storage, and then where's the bottleneck? And it could be anywhere, right? It could be a high performance input pipeline. It could be a bunch of different things. And the point being is, the bottleneck's not always up there right next to the model. Once you do load image to memory, then there's a whole nother problem. It's a data science problem. But all the time spent before in cleaning and transformation, in that data, in that subsetting and all that, that's still a bunch of challenges that have to be done. And so somebody has to consider the entire stack, okay? And again, if you can take your entire data set for your entire model from an AI perspective and load it into the memory next to the GPU, it's like, don't be awkward, but it's okay to walk out now. But that's not really that's not the real world. The real world is there's a bunch of data that has to be loaded from memory, from disk into CPU memory, where you're doing things like transformations into GPU memory and beyond. And so while a lot of people look at the system like this, and this may be where, we look at something like that NVIDIA Docker on the last image, right? So you look at a system like this, and you say to yourself, I mean, this seems all pretty well contained, right? But the answer is this is one Docker container. You may have hundreds of these, if not thousands, as you take your models into production and as you take your training into production. So we say, and you can look at it like this, and now you get into things like the actual hardware itself. You've also got those switches. You've also got network attached storage where you've now disaggregated your compute from your storage because you've got a data set larger that can be stored in one single box. But it gets worse. There's all these other things in here, versions and all these other things have to go about. How do you get a standard model image that has everything you need in it to be able to do something? And so you get into, it starts to get more and more complex, right? It's additive. All of you, and I saw somebody carrying a math book in here that I don't even want to know the answers to. The point is, you're all really good at math. You know what happens when you add complexity. A single system versus a ton of systems working together. You can do the math on that. You do it for a living. So every layer is an ingredient to overall training performance. And so a data scientist wrote this slide. Please don't take it offensively. Data scientists can be infrastructure or IT technology dummies. An example here is there's also out-of-band management for these exact same products. And there was a data scientist who was doing all of their training across the out-of-band management. Okay, so they call up and they're like, I don't understand why my training set's going at 1 gigabyte per second when I have 100 gigabit links between my GPUs and my storage. And the answer is as simple as choosing the wrong subnet, right? So sounds like we're saying something very pedantic, but in fact it happens every day. I've heard stories of startups that go out to Google, they get their free Google credits, they start to spin up Kubernetes, and they ask for 10,000 public IPs, right? There's a bunch of things that have to go on from an infrastructure perspective that are challenging when your focus is on doing things like getting models into production. So learn from those other data scientists' mistake. Again, you can see there where using a 1 gig app network would be suboptimal for your training, right? These types of things happen commonly. And so AI software is only as good as the AI hardware that runs with it. And so, again, like I said in the very beginning in the preface, data scientists shouldn't be infrastructure experts, but infrastructure does determine your success. And IT has to create that partnership. You really want to drag people in, right? So it's about building that bridge. I'm going to blank on who the institute is, somebody very important who does papers all day long. You talk about a survey of this thing that they're now calling sort of a helper or basically bridging those two areas together to be able to explain it from a business perspective. And so a lot of this is growing in the industry. So now, are you in pain? AI infrastructure should be scalable, flexible, and portable. That's scalability. For example, you shouldn't have to bring everything else down to run one large training job, right? So what does it mean to be able to scale things up and down and to be able to have that environment for you dynamically, right? Like how do you do notebooks as a service and large scale inference in the exact same infrastructure and scale them as needed? Flexible, again, this is from a tools perspective. So think of this from a tools perspective of tools change every day. Even in our own pipelines, we might have started something 2 years ago with something, just log ingest, something as simple as Logstash. And today, it's our syslog. Why did we change? Somebody hit a wall and some feature needed to be there and we had to move tools. How do you do those kind of things if you're locked into certain types of infrastructure, even certain types of design? And then portable, you want to be able to take this on and off cloud, and candidly between all your clouds, it's a multi-cloud strategy. So some of that's development, some of that's tooling, and some of that is as simple as how do you get object and high performance object both on-prem and off-prem so that you can take something, try it in the cloud, fail fast, fail cheap, and then how do you rationalize that project on-prem, and how do you get that high throughput object that you're used to? So when we say something like being able to scale, this is an example of TensorFlow and a checkpoint that we did ourselves in February 18. We built this checkpoint simply to show people that disaggregating compute from storage for GPUs is something you can do successfully. That's all we did it for. We made no other changes to the infrastructure whatsoever, and yet, roughly 18 months later, you're able to see that it was, I'm sorry, that's 6 months. You can see that it doubled, it's 2.5 times faster. Now you ask me why. Did I add something in there? Did I supercharge the flux capacitor in IT? No, it was actually optimizations in TensorFlow that the system got faster, and as a result, we were able to do a lot more things with the exact same infrastructure, right? So you have to be able to move with that software and consume that new software as it comes around, because you're going to get optimizations naturally. And so another way of looking at it is, you might also just do something as simple as increase your batch size, right? Something that simple, you have to be able to make those adjustments without having an impact on the performance of your projects and the things you're deploying into production. Okay? So, from an IT perspective, when you look at a pipeline, we look at it like this, right? We want to see all the things going on, whether it's our syslog or Kafka, you know, where's the disaggregated storage, how many clients, how many VMs, all these kind of things. But the other side of it, the things that the IT teams are looking at, is how do you look at it from this perspective? Where data flow is not linear, right? It goes in and out, you've got a pub-sub process, you've got all these things going on. This is actually our own internal CI/CD pipeline that we do a bunch of machine learning on our own project, our own product, to enhance the quality of our own software, right? So we do a bunch of regression testing and things like that. And this pipeline has changed, and that's other sessions. We actually presented that at Strata Data to show you the history of that. So, what we propose is there may be a need for a hot tier for AI. There's probably a lot of people in here who are using something like a data lake. And a data lake, or sometimes people joke about it and say something like a data swamp, and all these other kind of data fog and all these kind of things. The point is, there's a bunch of data that's been put somewhere. Challenge number one, it's been around for a long time, and most of the data that was put in there is not machine readable. So we go back to the beginning, which is that image loading process and all the things you have to do to actually get it available to be able to do things like AI and machine learning. The second one is, it also is not necessarily a performant tier. It's meant to store a bunch of data, it's meant to make it available, but as you've added things on to things like the Hadoop ecosystem, Hadoop adjacent things like Spark and all the other things we talked about on the other slide, there are challenges, and those challenges are, we need real-time, high-performance outcomes. How do you put a GPU and machine learning right next to something that's supposed to do simple map reduce in the exact same infrastructure, right? So you need to be able to shift and change accordingly. So whereas we look at a deep learning asset as something as simple as this pipeline, there's a ton of things that happen before you actually get to that portion of the pipeline that need to be addressed. And that's what we're talking about from an infrastructure perspective. We're not going to prescribe exactly how to fix that. You know, we might do that offline, but the idea being is you really have to think about all the other things that happened well before you got the data adjacent to the GPU. And then the other way to look at it is you've got an evolution. So I'm going to look out here. We see this a lot where we come to a conference, everybody stands up here and says, look at these great models I have, and they're all amazing. And then if you pull them to the side and you say, okay, how many of those models do you have in production? Well, they're like, well, I mean, this is mostly theoretical. We need additional hardware, so I've got one in production. Right, and the goal is we've got to get hundreds. So first of all, don't think that you're behind. There's a lot of people that are still in traditional analytics. There's a lot of people who are still doing kind of descriptive batch analytics and things like that. But the reason everybody's here is because they're heading towards predictive and transformative analytics, right? So how do they automate? How do they do decision support? And how do they do that across the entire mission or enterprise or whatever it is that you decided to learn data science about? And so that's a relationship of the amount of data you have as well as how mature you are from an organization. And if the IT organization isn't supporting this trajectory, there's going to be a bump in the road, and it's going to be a significant one. And maybe everything gets lifted and put somewhere else, or simply kill that project. Those kind of things happen all the time. So I mentioned earlier, by the way, this is not intended to be read from the audience, and I apologize. You can look this up at Matt Ruck's website every day. He publishes every year. It's amazing. The whole point of this is there are a few good tools. I'm not telling you any of these are important. What I'm telling you is there's a ton of tools out there, which is why the flexibility in your environment to be able to pick and choose tools, to be able to disaggregate and modify your pipeline depending on what you need. And if your mission changes, you've got to be able to take those tools and change them, is extremely important from an infrastructure perspective. This is what you expect, which is to show up with your tools and say, I'm ready to work. The question is your IT expecting the exact same thing? So now we can talk a little bit about orchestration adjacencies. I'm not saying some of these may actually be here, by the way. I'm not saying any of these are exactly what you need, but the point is, everybody talks about Kubernetes and their infrastructure environments. If you haven't talked about it yesterday, you'll talk about it tomorrow. There are probably 19 different companies in here touting how they're adjacent to Kubernetes, which is really important. Kubernetes is a platform by which you build your platform. How you do it, all the rest of it is based on these adjacencies. And so the goal here is you buy or consume certain tools that are going to speed you up to data scientists, to data science. You're going to build that custom code on top of it that makes you unique, or is basically your core competency, right? So what we don't want everybody in here doing is trying to build their own Helm or MicroK8s or Polyaxon. Go grab one of those if it makes sense to your pipeline, and then plug your customizations and your proprietary information on top of that where it makes sense, right? So get the speed where you need to, because it is all about speed. So this is an example with orchestration. If you're running Elastic, for example, with one line, simple as this for us, you just type in pure file. We have something that plugs into Kubernetes and lets you deploy ECE, which is Elastic Cloud in their entire suite. I hope they're here. This is a plug for you. With one line, they can deploy the entire thing on Kubernetes just like that. So when you think about development, and rapid support of your environment, if you said, hey, I need a log search environment for my pipeline tomorrow, it's that easy to add it in a flexible environment where IT understands the needs of data science. And so the other thing that we will tell everybody, and this is something IT owes you, which is the observability of not only your pipeline, but the actual infrastructure that's supporting that pipeline. Because if you come out today and say, this isn't going fast enough, if we don't know what perfect looks like, we don't know what to measure your pipeline against, right? So giving you those micro metrics, and by the way, PyTorch doesn't have those metrics naturally built in. You have to build them in, those kind of things. So we want to automate it. We want to make it fully observable. And then of course you want to visualize it, because some people like pie charts, right? So you want to be able to do those things as well. So as we talk about IT leading the charge, everybody's leading the charge, right? This isn't just an IT-focused conversation. The idea is you have to assess those current pains. What exactly does it mean? You know, I've talked about 5 or 6 different pain points. There's 100 out there. We need to look at what those are and then understand it and communicate it in an open forum. We talk about things like, we see them out here, DevOps, MLOps, Data Ops, all of those. The whole point of any of those mashed up words is about the idea that there's a bunch of people at a table who have a bunch of different competencies talking openly about sharing that information. And by the way, make sure security and the lawyers are there too, because otherwise they'll stop you down later, right? So everybody needs to be at the table. Now the next one is aim at goals of varying length. The whole point being is, if you have a 3-month goal for your infrastructure, you're not deploying appropriately at the speed you're probably moving at. If you have a 1-year goal for your infrastructure, you're getting there. And you can't necessarily, I just told you about how your tools are going to change every 6 months. You're like, you're crazy if you're telling me to go past 1 year. You're not going to set lines in the sand, but you kind of want to have a general idea of where you're going, right? You're all very good at things like modeling. We want to have 5 or 6 different models of how the projects are going to go and what kind of data feeds we're going to add and how that's going to scale, how many models we're going to have at the end, and what we need to support in production. And so if you don't know what those goals are, even if they change, you're not ready, which means IT is not ready. And at the end of the day, especially being a data-driven organization, we want to talk about enabling more data, okay? So from our perspective, there's obviously, everybody understands machine learning and AI, the more data you give it, the more intelligent it gets. There's certain technologies that are allowing people to put a little bit of data in there and get pretty good success. But at the end of the day, the more you have, he who has the most data wins. I think that's Google. Everybody else makes those quotes. So that's very important as well. So we appreciate your time. Do you have any questions?